Yes, we have here an example. No? The equation of the effective stress failure envelope for a loose sandy soil was obtained from direct shear test. This one, no? And a drain triaxial test was conducted with the same soil at chamber confining pressure of 10 pounds per square inch. Meaning, chamber confining pressure, this is sigma. This is sigma 3. Kung tanaw ni mo sa, let me have, ito na siyang erase para di ta maglibog, no? Tanaw ni mo sa figure. First is we are required to calculate the deviator stress at failure, meaning deviator stress, this is actually the diameter of the more stress, no? Or this is the diameter in more circle. Deviator stress at failure. So, kung imong tanawon, from here, from this point to here, this is normal stress, sigma. Then, mauna siyang tangent 30. This one is 30 degrees. So, mauna ang tangent 30 degrees is equal to shear stress over the normal stress. So, that kana ang equation is nahimo na siya is equal to sigma tangent 30. So, we are required to determine the value of x times 2 because here x is the radius only. So, unsaon mo na siya? We can have, because this is 90 degrees, so to get the value of letter A for the deviator stress is actually equal to sine 30 degrees is equal to x over sigma 3 plus x, no? And remember, sigma 3 is equal to 10, no? So, mo nang in here, the solution is sigma 30 is equal, sine 30 is equal to x over the minor principal stress, which is 10 as given, plus x. So, that the answer is 10. But since deviatory stress, deviatoric stress is actually the diameter of the more circle. So, maunang times 2. So, the answer is 20. For letter B, estimate the angle that the failure plane makes with the major principal plane. So, that is theta, no? This is theta. Ang pasabot niya ani, this is theta. Estimate the angle that the failure plane makes with the major. This is the failure plane, no? Makes with the major principal plane. So, the major principal plane is actually sigma 1. So, iyang refer ani is theta. So, to get the theta, that is theta is 90 minus phi, no? Mo nang 60 degrees, no? Or kung imong tan-awon dire, this is actually, this angle here, this is actually phi, no? So, mo nang, since this is 90 degrees, 90 minus phi is theta. So, theta is 60 degrees. Then, for letter C, or 180 minus phi minus theta, minus 90, or 90 minus theta is phi. Or actually, this one, this triangle, para makuha ni mong letter B, this triangle is 180. Then dire is 90 man, di ba? 90 man siya, minus 90 degrees, minus theta minus phi is equal to 0. But 180 minus 180 minus 90 is 90 degrees. And to get theta minus phi, is equal to theta. So, munang theta is equal to 90 minus phi. For sine theta, for letter C, determine the normal stress at shear stress and shear stress when the specimen failed on a plane that makes an angle 30 degrees with a major principal plane. Determine the normal stress and the shear stress. So, normal stress, this is sigma, and the shear stress, this is tau. When the specimen failed on a plane makes an angle 30 degrees with a major principal plane, so that is sine since theta, this angle here is 60 degrees, this angle is 60 degrees, so munang sine 60 degrees is equal to over x over 10, or sine to get the value of shear stress. Shear stress is yes, x, sakto dahil. Because sine man, so muna siyang x dire. So munang sine 60, that is shear stress over x. But remember, x is equal to 10, which we computed earlier. Munang kaning sine 60 is equal to shear stress over 10. Kung tanaw ninyo ang figure, more circle, the sine 60, this is the shear stress over the x. Kani. Shear stress over x, then 60. Siya. So that the shear stress is equal to that one. And for the normal stress, because we are required to determine also the normal stress, sigma, the normal stress is equal to, we can get the normal stress from here, that is tangent phi is equal to shear stress over the normal stress. But the phi, tangent 30 degrees, is equal to, the shear stress is, na-solve naman na siya. Kana siya, di ba? So, na-solve naman as 8 point, di ba? Ganina, that is tangent 30 degrees is equal to shear stress over the normal stress. And tangent 30 degrees is 8.66 over the normal stress. So that normal stress is 8.66 divided by tangent 30 degrees. So muna siya ang answer sa question for normal stress and shear stress. If you try to look at this triangle, kani siya nga triangle, masolve nimo ang normal stress, because normal stress is from here to up to the shear stress. Then another example, I think we have to continue with, or you can, okay, we'll try to continue the next example.